never seen the wiring methods before, I cannot, chapter 4, I'm sorry, chapter 4. Um, since a lot of you guys have never seen the wiring methods, it's so important to read this chapter. There's a lot of tables in it comparing different wiring methods, Patrick, with each other, the difference between MC and AC cable and what's not. In plain English, guys, I always explain to the people, this one, your wiring methods of choice if you're doing what? Residential, plural. This guy, the one that does not have insulation, your wiring of choice, if you're doing residential, you can use it residential, but typically cheap commercial projects. If a cheap commercial project, you want to do it, what do? AC, they call it AC cable. How do you know it? It's not insulated. This guy, the more expensive cable, the MC cable, the insulated ground, is your wiring of choice if you're doing commercial industrial with cables. That's it. The wiring of choice. Now, EMT conduit, again, if you're doing commercial, industrial, your conduit of choice, the way they use the conduit and the cable, they use a combo of conduit and cable, guys. So here's your panel right here. They take a bunch of conduits out of this panel all the way to a boxes in the ceiling. So they bring a bunch of conduits to the box from right here, right? And from there, they use cables to tie all these equipments to that circuit that's coming into the so they have like they will bring 6 circuits, or typically they bring so there will be they'll bring 8 circuits inside this 3/4 inch conduit, 8 of them, into a box, a bigger box like this. Now we have 8 circuits sitting in that box. Now you distribute these circuits in 2 ways, either more conduits going elsewhere to distribute these circuits, or when you get closer, cheaper would be to take the cable, the AC cable, and I will tie it to a lighting fixture. Here's an AC cable, bam, bam. Take this fixture to the second, to the third, to the fourth, with with MC cable like this, and bring it back to where? To the box, and tie it to the wires that's coming in the conduit. So 90% of the time, when you do commercial, you're doing combination of these 2 wiring methods. So MC cable for branch circuit home runs. The home runs is almost always. Home runs are almost always um, EMP, they call it EMP conduit, almost always. And going from the home runs into the individual receptacles and lights, they use MC cable. In dwelling, since you guys are doing dwelling, you almost always use this type of cable. They come in different colors. This is the white one. Everybody, what size is the white one? You have a white. The white one is 14, different color coded, not code, but industry. The yellow one is 12, and the orange one is, keep going, 10. So, and the black one is 8. They have a black, they don't have a black. The black one is 8. So not industry code, that's the color of the cable. So the inspector, when they walk in, this is supposed to be in the kitchen. 2 of these supposed to be in the kitchen. So look at how easy for the inspector. Walk into the kitchen. If he doesn't see this color, you're doomed. Just by walking in the kitchen and looking, do I see this color? Yep. Then I'll go check. If I don't see this color at all, then where's your 220 amp circuits in the kitchen? See how they make it easy? If you're tying it to an air conditioning, if you're doing an air conditioning, if you don't see this color going there to the air conditioning, and the wiring with and you see this color going to the air conditioning, you made a mistake. It's supposed to be number 10 going to the air. See how they made it for residential really easy to do inspection for electrical inspectors? Okay, so that's what we're going to be doing, guys. A few of these. Let's go over um, conductor sizing. I walked you guys through a lot of conductor sizing. We'll continue to talk about conductor sizing. You guys are designers. I'll walk you one more time about conductor sizing. Types of wire methods, 60 of them in an EC code book. You probably will be using 4 or 5 commonly used. So we'll look at them right now. Wire connections, when you bring your conductors, you have to land in a lug. This lug is so important, as well as this cable. So when you tie equipment, guys, you don't just tie them up in the air. You take a cable into a lug. The conductor have to land in a lug. These lugs have to be rated for certain things. We'll talk about this. There's some concept called voltage drop calculation, guys. I don't know if I will be able to do it today, but we will do voltage drop calculation. Long story short, if you start with a voltage 240 right here, and you move all the way here, here's 200 feet. Do you guys guys expect the voltage right after 200 feet to be 240, you have to use a superconductor in order to achieve that. So right here, you might, at this voltage, you might drop your voltage to 230, depending on what conductor you do. 230 voltage. Most of the equipment are rated good for 230, so you're good to go. Now, the drop that you can do typically in feeders and branch circuits are 5%. So you can drop this voltage down up to 5%, and the equipment's still okay with this. It will function, it will work. We'll talk about these 1 voltage drop in a second. The neutral, and I told you guys the beauty of the NEC code, the beauty of the three-phase system, and why the three-phase system is superior, is because you can take 3 wires, and if you balance the load, the 3rd wire is carrying nothing, the 4th wire is carrying nothing, right? So the neutral always carries the unbalance between the 3 phases. Anybody remember what the exception that we talked about, Jay? Harmonic. Harmonics are the exception. Why? Because they are like my kids when my son, when he was a baby, they're sloppy eaters. They don't eat, they don't digest electricity in a linear way. That's where the linear, non-linear. Linear, when you eat polite, that's always the explain. If you're linear, if you're eating really polite when you eat hamburger, you're unlinear if you just put the whole hamburger in your mouth. That's unlinear. In plain English. Okay. Determine the current carrying. So it's a concept that called current carrying capacity, guys, or so-called ampacity of a conductor. I walked you through the table. I will walk you one more time through the table. If you guys understand how to use the table, Brandon, this time, from now until you graduate from Dunwoody and you continue to be at work, you will be really good in terms of ampacity of conductor. That's a major thing that they do. So we'll talk about this one, guys. Over current protection device and sizing it. I told you guys that whenever you need to pull anything, you always have to start with circuit breaker, and then you pull with a lug here, tie it. In between them is a cable or conductor, and at the end you have another lug, and you tie to the equipment. That's typically how you pull. This is my AC system. I have to start with a circuit breaker. I have to pull a cable or a conduit and wire in between them. It has to land on a rated lug on both ends. And all these, the lug from this side, the lug from this side, and the cable, and the conductor will decide the ampacity of the system, the ampacity of the whole circuit. The weakest link, remember that 60, 75, 90? You choose the weakest link. So if that was 60, the cable was 90, and this one was 75. When you size, which column do you go to? The weakest link, 60. Aluminum, God forbid aluminum. We don't use a lot of aluminum wires, guys, in branch circuit. We use them in feeders. Aluminum wires is just as it says. The wire, the conductor inside the cable is aluminum. Utilities use them all the time successfully in a lot of applications. Inside buildings, guys, we don't like them, especially engineers. You'll see a lot of engineers shy from using aluminum because they expand and contract at different rates, and they need a lot of maintenance. So if you have a building that have a good maintenance crew, aluminum is perfect for it. Annually, they go torque all these lugs and maintain them. If you have a building that doesn't do a whole lot of maintenance, put copper there, it sits for a long time, you don't have to worry about it. So that's kind of the rule. For branch circuit, we rarely use smaller branch circuit aluminum. To teach you guys the installation requirement for all wiring methods in the NEC book, I probably could have spent one whole semester just teaching wiring methods. We're going to pick the most important ones and we'll talk about it. You're going to continue as you use the code, guys. You're going to continue digging in. So, Brandon, you see they're using a cable tray at the airport. So you go to the chapter 3, look at the cable tray, and it will tell you how to size a cable tray. Does that make sense, guys? Because we don't go over cable trays. It looks like a ladder, and you put the cables inside it. But there are rules how to put the cables. You don't pile them up. You have to separate them with a one diameter of one conductor. So one conductor space of a conductor, another conductor, and how much current the conductors can carry in a cable tray is different than in a cable. So there's a few rules. Service entrance conductor, guys, that guy. This is the wiring method that they bring to your house, the utilities bring to your house directly and tie it to, connect it to the grid. We'll talk about voltage drop calculation, like I said, to non-metallic cables into top of And there's wiring, there's different wiring methods, guys. We'll talk about ways of bringing all the NM cables into the panel. NM cables into the panel. I hope you wouldn't graduate from here knowing how do we measure or size the conductors in the US? AWG, right? How do we do it in Europe or anywhere else in the world? Millimeter. So if you're working on a project like Mashhad somewhere else in other part of the world, remember they use millimeter squared. So in the US, from millimeter into what do we use? The AWG. What does it stand for? American wire gauge. So any comments, guys? Any questions about the AWG versus a millimeter? Millimeter. So when I have 4 out what? AWG. So important to know the AWG. The weirdest thing is, that's weird. I found it weird, because I came from a metric system. The higher in the metric system, the higher the number, the bigger the conductor. In the AWG, the higher the number, the smaller the conductor. It's kind of counterintuitive. So, for example, a wire gauge 40 AWG and a wire gauge number 1 AWG. Which one is size higher? You should know that. This is higher. You know what the size of this number 4 is? Smaller than your hair. The size of that wire, 40 AWG. That's how the minimum that they can go. It's almost a hair size. Now, if you go to the metric system, then it starts with 1.5 millimeter, go all the way to 30, they go higher than that, 36 millimeter. Which one of them is larger? That does. So get used to that one. I have students who have never wired and they just get confused all the time. Oh, you're telling me that number 12 is bigger than number 14? Size-wise, I'll get used to it. So just set your mind. Guys, when you are designers and engineers, you can, I can, when I was in college, we used to do things, I can make the east-west and the west-east. And if I give you an assumption, the east is the west and the west is the east, and run on this assumption, you as a designer, as an engineer, you should be able to solve problems. As long as you know what the assumption is. That's with x equal 5, right? With the whole algebra, x and y, if I give you any value for x and y, you can solve the problem. Same thing. Things define what you want, and then I'll run with it. That's the same thing. The definition here, higher, smaller wire, bigger wire is the lower. Okay. Lifting wires can be single strand or multi-strands. They can be stranded. If you put a conductor in a conduit, this is probably the most important thing. Only if you put it in a conduit, then larger than number 8, you have to strand it. If you put in a conduit. So let me tell you about stranded versus solid. When you do commercial industrial, 100% stranded wire. Stranded wire is easy to pull in conductors, guys. Very easy to pull in a conductor. Very easy. Stranded wire in conduits. If you're doing in conduits, stranded conductors. If you're doing residential, typically you're using cables. If you're using cables, you don't worry about stranded. They come solid in the cables. But when you're doing conductors on a conduit, 99% of the time, you will be running, guys, stranded conductors for everything else. What does the code require? Only require you, if the conductor is in a conduit, larger, number 8 and larger, then it has to be stranded. Only if you put in a conduit. Now what happens if you don't put in a conduit? Doesn't matter. Anybody knows why we want number 8 and larger to be stranded in a conduit? Have you ever pulled a number 8 in a conduit that's not stranded? Pain in the butt. It's very hard to pull solid conductors, guys, in conduits. Very hard. Stranded, they bend easier. So, any comments, guys? Any questions about stranded? So, stranded, solid. If you're doing commercial or industrial, everything is stranded. If you're doing residential, everything is solid, almost. And that's the rule. Stranded. Well, if they have they have the one wire. Sometimes they have one wire, but almost all of them. Yeah, when they do these, they have steel in the middle, and you've done a lot of them, don't you? They have steel in the middle and aluminum or some type of alloy around it. Anybody knows why they have steel in the middle? The weight. Yeah. That's why they, remember, you're stringing them between poles and wind. So for weight, physical, mechanical weight. So they put steel in the middle of them to hold them. And they wrap all these aluminum conductor. What they call ACSR. So aluminum conductor, steel reinforced. That's what the typical for these. We rarely use this one unless you're doing industrial. Then you start doing things like this. That's part of I'm going to say, can I dare to say part of the 3% lucky ones who will be doing medium voltage or industrial that will be using this type of wiring. It's not even in any secret book. Makes sense? Not in any secret book, this wiring method. Okay, ampacity, guys. Carrying capacity is in table 3.15. We'll talk about this table the last time. These tables, guys, are for ambient temperature, 30 degrees or 36 Fahrenheit. What happens if you go higher or lower, like we talked last time, than 86 degrees Fahrenheit? What do? You derate. If you go higher or lower. Typically, if we go lower, we don't do anything. You know? But if you go higher, you must derate. Am I making sense? So if you go higher, you derate. If you go lower, who cares? They will carry more current than what you're sized for. The table for derating, guys, is this one. We'll be looking at it in a second. We looked at it last time. If you guys remember, we were looking at the temperature. Wire diameter. What's a mil? Then after the conductors, guys, we take from 40 all the way to number 1, and then they go 4/0. I'm sorry, 1/0. After that, the way they do them, they go 1/0, and then 2/0, 3/0, and 4/0. That's another range, and then they go 250 kcm to 2000 or something, 2000 kcm higher. These are how we ran them in order. So the smallest is 40 AWG to 1, then we go to the aughts, 0, which is 1/0, 2/0, 3/0, 4/0, and then 250 all the way to 20 kcm. Now, what is a mil? kcm and the circular mil, and 1,000 a kcm. K is for 1,000, C is for circular, and M is for a mil. Now, what is a mil? You guys studied that one with Polly when you did that one? So the mil, very easy. The mil is 1/1000th of an inch. That's what a mil. What happens when you square a mil? With circular mil is a square mil. So you multiply this by 1, 0, 0, 1. That's what a square mil is, or a circular mil is. A mil is 1,000th. A square mil is a mil multiplied by another mil. So whatever that number will get you. So in this case, that will be 1 times 10 to the power 1, 2, 3, 4, 5, 6, minus 6. So 1 over a million, right? 1 over a million is a square mil. So when you say a kilomil, then you multiply this number by what? By 1,000 to make this a kilomil. So or you have this is a mil. To make it a K, you multiply this number by 1,000. That's what get you a kilomil. So that's how they come up with circular mil, kilomil. In the metric system is easy, guys. You take the diameter, half an inch diameter. That's the diameter of that cable. So a half an inch millimeter, that's half an inch millimeter, the diameter of that cable. So that's your mil and circular. Any question, guys, about the mil and the circular mil? In terms of that one. Conductors have to be protected by circuit breakers. We talked about this one. I want to go over these very important branch circuit boards one, and I would like you guys to, I want to start with this circuit. Remember, these are the most common branch circuits. These are circuit breakers that you put in your building. Let's go to the 15th. This is your general branch circuit. In a dwelling, guys, Ignore this one in a commercial. In a dwelling, this is your general branch circuit in dwelling. Anything that the code doesn't tell you to use 20, what do you use? 15. Almost everywhere else, except, that's your general. Light and receptacle. By the way, it's L for light plus R for receptacle, both. All right, what wire size do you use with this guy? Number 14. Okay, so now let's go to the next one. Next guy, where do you use a 20 amp circuit in a residential?
Kitchen.
Thank you. How many for the kitchen? So right here, this one for 2 for kitchen. Okay. 1 for bathroom. What else? 1 for laundry. 2 for kitchen, 1 for bathroom. Outside, no. You can. The garage doesn't say 20. It has to be a dedicated circuit, but it doesn't have to be 20. It's a good idea to be 20, but it doesn't have to be 20. But I would put it on a 20 though. How about sump pump? If you have a sump pump equipment. Another place that we do sump pump. These are the 20 amp circuit. What wire size do you use? Quick? 12. Thank you. All right, so let's go to the 30 amp. Where would you use this one? AC. Thank you. What else? Dryer. Dwelling. So these are the 2 places. What size wire do we use, gentlemen? 10. Thank you. 10. Okay. I want to add to the wires the voltages. What voltage we typically use with the 30 amp? 240. This is a 240 circuit. What voltage with these 2 guys? 120. You can see now, you go higher than 20 amps, almost always you're getting into the 240, 2 Hz. Am I making sense in terms of wiring? Okay, so now let's go to the 50 and 40. What do we use these for?
The range.
Range. Fixed standalone range, big range. What size wire do we use? You gotta remember, we're going to range. What voltage? Always 240. 230, which is 240. That's it. If you guys know this, you have known all the branch circuits in a dwelling.
I have a question on one of the chapter questions. It was
Yes.
like, who is to supply and furnish the range?
The owner. As an electrical contractor, do they require you to buy the range? Think about it. I know you don't know, but typically, and that's kind of the mechanical equipment guys who supply any mechanical equipment or owner equipment. Who supplies and design the mechanical equipment?
The contractor tries to give them like a deal or a package deal or buy everything.
I hear you.
One person.
But typically, when you work on these, the owner equipment, I can suggest the owner equipment, the mechanical equipment are supplied by either the owner or the mechanical engineer. So we don't typical. I'm not saying that fans in the bathroom. I mean, I've done a lot of fans for the owner in the bathroom, but in a commercial industrial project, you don't mess with fans. The fans specified and sized and installed by the mechanical contractor, and all what you have to do is just go for it. If you're going to see soon when you go in the industry, otherwise you're stepping into somebody's toes. There's respect between disciplines and kind of, you don't want to aggravate people. You're taking work away from certain people too. See what I mean? You know how that goes. Okay, any question guys about these branch circuits, gentlemen? Any question about these branch circuits? Okay, so that's basically what the most common circuit in dwelling. Now, if it's in a commercial guys, the only thing that you dropped, anybody knows what we dropped in a commercial? 15 amp circuit. Typically, can you use it? Yes. Good idea not to use it. So when we do commercial industrial, you start with number 12 wire and 20 amp. Lights or receptacles. Done. That's your rule. In dwelling, we use 20. In commercial industrial, we drop that 20 circuit. So, okay, we talked about 20 amp small appliances circuit, guys. We just finished talking about this one. We talked about the range. We talked about all these, right? 50 amp ranges. They use the words fastened in place, the big fastened in place cooking equipment. Because if you have Your cooking equipment, guys, come in four formats: either an oven, standalone oven, or a cooktop, or an oven or two ovens with a cooktop at the top, all built into some big thing that's called range. You know, that's what when they talk about 50, they're talking about typically a two ovens and a cooktop built in one standalone format. Am I making sense? Now, if you have just a cooktop, you could get away for a cooktop with a 20 amp circuit. Or an oven, you could probably get away with a 20 amp circuit for an oven. But a range is typically two ovens and a cooktop built in, standalone, and electric, not gas. Heating and AC equipment, guys, over 50. Now, what happens over 50? Now, we're not talking residential. Rarely, if ever, you'll see anything larger than a 50 amp in a dwelling. I've never seen it, but it could, you know, one of these mansions, they have other things. But the typical house would never see over 50. Now, why would you use over 50 as a branch circuit? No. Restaurants, yep, you have a cooking equipment, 60 amp branch circuit for cooking equipment. How about you go commercial now, air handling unit? That's a branch circuit, 100 amp, 150. Chiller, 400 amp, 400 amp branch circuit for a chiller. So that's you start getting, see how the bigger amps, and they're not feeders. Remember the difference between feeders and branch circuit. They're not between two panels, between a panel and the equipment they utilize. So you go over 50, you're looking at industrial commercial. Almost. Are there any limit on the size of a branch circuit that I can do? No. Can I pull a 4,000 amp branch circuit? Yes. Typically it doesn't happen. You can pull to pull guys an equipment that can pull 1,000 amp. That's not unheard of. 1,000 amp branch circuit going to a piece of equipment. In industrial, that's not unheard of. So imagine 1,000 amp, not panel, just one piece of equipment consuming it. Imagine the service. So no limitation how high you can go in amps on the branch circuits. Typically, the only limitation, guys, that utilities do in our area, and a lot of utilities, they don't want you to go higher than 3,000 amp service. 3,000 amp service. Typically, sometimes they push it to 4,000 amp. And who decides these limitations is the utility. Now, what happened, Brandon, if you need more than 4,000 amp for this hospital? What did you guys do when you were doing utilities? Another feed. Give you another service. No problem. You need 8,000 amp. That's a huge hospital, though. 8,000 amp, no problem. We'll get you another service. Here's one service here, 4,000 amp, and one service here, 4,000 amp. Do you need more? Bring it on. A third one. That's rarely, if ever, you will see more than two services coming. If you need more than two services, what we typically do, guys, we start going to the medium voltage. So the utilities start giving you, instead of giving you a 480 system here, we drop the 480 if you need more than two services, and we start giving you a 13,800 volt service. They call it the primary. They start now, you get your 13,000 like Mayo Clinic and Ganda building that we did. All these buildings, a huge building, they start raising the voltage high. Then 1,000 amp is all what you need at this voltage. That's 1,000 amp at this voltage, guys, is you're looking at probably 25,000 people in a city. That can feed 20,000 people in one city. 1,000 amp at 13.8 is a lot of amps. A lot of amps. See how they've solved the whole power consumption industry? Okay, aluminum. Like I said, aluminum conductor, the utilities use aluminum all the time, guys. They have the crimp connectors, they use them and they're successfully used. Aluminum conductors have shown in the industry that they contract and expand at a higher rate. If you have a lug that expands and contracts at a higher rate, over time, what's going to happen to the wire? Get loose. Loose wires arc and spark. If you're lucky, you short circuit breaker will take care of it. If you're not lucky, you start the fire. And it's highly unlikely, guys, to start the fire when you're arcing and sparking in a box like this. I mean, it will take a long time to burn this. It's made to handle good heat here. That's why they want you to put them in a box. That's why they don't want you to do the connection up in the air or inside the walls. Because if you have arc and spark, you contain the fire. You don't burn the building. So and receptacle switches must be suitable. Almost all the 15 and 20 and 30 amp, 15 and 20 amp equipment, guys, are almost always copper. We do them. Higher than that, we start using aluminum or copper. If you're working for an engineering firm, guys, most likely you will be using copper. Um, and the same thing, copper or aluminum, you have to fuse them. If you guys were looking at copper and aluminum, what's the advantage of copper?
Cheaper. Oh, no, it conducts better.
It conducts better, so it gives you more amps, and it doesn't expand and contract, so it's safer. Copper, two words for copper. Safer in terms of arc flash, arc blast. It doesn't expand as much, and it conducts more, and you have smaller conductor to carry the load. Aluminum have two advantages. Three, probably. Okay, cheaper, less money. Lighter, less weight. That's an advantage when you're having bigger feeders. Less weight. Actually, the two advantages. The rest is a disadvantage. So cheaper in terms of money and less weight. So what's their disadvantage is, well, they don't conduct as much current, so you have to have a bigger conductor for the same load. And they expand and contract at a higher rate, so you do have to have a preventative maintenance in your building, which a lot of people do. So every year you go torque or you thermal image all the logs, and the one that's about to get loose, you go just torque them. And they put some material, guys, to handle the expansion and contraction too. So that's basically your aluminum versus copper. Utilities use aluminum successfully over the years, guys, outside all the time. You don't? Uh, you have to have a connector. Yep. Yeah. It's corrosion, yeah. When you tie copper to aluminum, it's a bad idea. They have a special connector where they don't touch each other. They make a material that take the copper to the aluminum. The reason because they expand and contract at a higher rate, and they actually expedite the problem of arcing. Yes, sir. No? Oh, I told you it's dangerous to stretch here, man. Okay, this sentence, over the years, guys, drove the people nuts. This particular sentence. Rating of the overconduction device determines the branch circuit rating. Very simple, but it will drive you nuts. Let me give you an example. Take this. I have 15 amp circuit that's feeding a load, and the conductor is number 14. What is the rating of this branch circuit? 15 amp branch circuit. Okay, no problem. I have a 15 amp branch circuit with number 10 feeding a load. What is the rating of this branch circuit? 15. You don't look when they say what's the rating of this branch circuit. They go by the circuit breaker or the fuse. They don't go by the conductor. Why? Where would you use number 14 indoor? Where would you use 15 amp on number 10? Parking lot. Why would we use a bigger conductor on a number 14? Are we nuts? Have we lost that? No, voltage drop. They use it all the time. So when you have, especially the commercial, it's not unheard of to use a 20 amp circuit, guys, with a conductor number 8. Very common. 20 amp circuit with number 8 conductor. Going to where? To the parking lot. So that circuit could be 600 feet, 700 feet. And why do you need a bigger conductor for a 20 amp circuit? Because you lose voltages on the way. So all of these, the rating of the circuit is the rating of the overconduction device ahead of it. That's it. So please be aware of that one, because the conductor change. The conductor depends on the voltage drop, can go higher. Okay, when we talk about aluminum, guys, we talk about the extra installation procedures to prevent the fire because expand and contract. So they have some material that they put on the lugs, so it helps with the expansion and contraction. There are different type of connectors when it comes to them. Here's the most common connectors that they use in the industry, guys. Probably in residential, you are looking at these. These are wire nuts. You guys are familiar with the wire nuts. I don't have a few wire nuts, right? We should get you to wire a few. Wire nuts. So you take two wires, up to 3, 4 wires under one wire nut, and you twist them. What's the disadvantage of this? There's limitation though. Can you guys see 18 all the way to number what? Number 6. Now what happens if you want to go higher than number 6? Are there special wire nuts, or you need to go? So this one will get you all the residential. Okay, you guys put resi, you're done. When you come to residential, you're here, done. And commercial too, up to this would get you up to circuits probably. Number 6 will give you we brought this up to circuit number 50 amp. Up to a 50 amp circuit, guys. So look at this right here above your head. 20 amp circuits, 30 amp circuits, 40 amp circuits, and 50 amp circuits. You can get away with wire nuts. No problem. Done. What happens if you go to 100 amp wire, high 100 amp? Now you go up to these guys. Properly crimped tabs. Here's another one connection, guys. These can go from number 20 all the way. Look at that big boy. 500 kcm. Right? Now you tab a feeder. Now you go to this crimp, okay? So these are basically what would you use this one? Commercial, industrial, and I can't emphasize the size of the conductor. Now, if you want to do a bigger conductor than this, guys, they have also lugs and cramps that you can do. These are crimp type wire connectors, not commonly used, but they are for these sizes. You crimp them 16, 14, and 12. If you're doing commercial industrial, like I said, bright circuits, you're talking about 15, 20, 30, 40, and 50. Oops, 50. All these bright circuits. And when you do the termination in the box, what you're looking at here? Why not? You go higher than that, now you're going into that crimp, properly crimp. Crimp, you guys, utilities use crimp all the time. They like it. So that's basically the connectors. Any comments, guys? Any questions about the first two are the most important ones. The top one is for higher circuits. The lower one is for smaller circuits. Lugs. Now these guys, what we typically do with these inside a box. So you grab a box like this, and you have a junction box, and you use wire nuts or crimp, right? Typical. Now, when you land the cable into a piece of equipment, we use lugs, connectors. So they use lugs like these guys. They can get them, again, number 4 all the way 500 kcm with a bolt or screw right here that you can put your wire, tighten it, torque it, and then from the other end, attach it to, from this end, what do you guys attach it here to what? To another connector with a bolt. You tie to equipment. This is how we typically tie to equipment, okay? Through a lug. A lot of equipment guys comes with this lug sitting on it. All what you have to do is just bring your cable, torque it, right? If it doesn't, then you put your lug here, and they have to get you a hole where you can line these two holes together, put a bolt on them, and torque them. Okay. So this is your cordless connector. We have also crimp connectors or compression connectors. The difference between these, there's a bolt here, you compress it. These are, look at the number, 8 to 1000 kcm, utility type. So to bring a cable, guys, here's my cable. This is a 4-aught cable. They have a connector on it. They crimp the connector on it, and instead of torque it, the bolt, and then they attach the connector to the piece of equipment. So, rarely, if ever, you see these in residential. And split bolt is also common, guys, where from number 10 to number 5,000, split bolt, you hear about it all the time. The nice thing about the split bolt is what happens if you you have a feeder like this, and you want to tap it. You want to connect it right here. So you have two ways: either you cut it, or you strip it a little bit here, right? And then you bring your connector like this. Utilities, you guys like them, you know, without cutting through the cable. You just strip the insulation. You attach your wire here under the set, and you put your split connector here. You don't cut the wire. Great tool of tabbing. They call it tabbing the conductors. What's in it for you guys? You're project engineers and project designers, and that's going to be your job to look at all these different type of connectors. Any comments, guys, questions about that? Yes, sir, Brandon? No. So I can't emphasize these. Typically, this is tied to equipment. And again, typically tying to equipment. This one, tabbing a feeder. Commonly used, tabbing a feeder, they call it tabbing a feeder. Engineers don't like it a lot, but contractors love it. So what they do, guys, is they have a gutter like this, and inside it a 500 kcm, 500 kcm, right? Now they want to tap this conductor. So what they do, they get rid of the insulation here, they put the cable, and they go to a disconnect, and here's number, let's just say number 6. There's rules for tapping. And the split bolt right here, and when you put a split bolt right here, of course you have to put insulation over it. So you tape it. All these need insulation, especially if they're, depending where they are, especially this one need insulation. Here's phase A. What do you do with phase B? Same thing. How many of these split bolts do you need for a 3-phase 4-wire? 4, 1 per phase. Yes, sir.
Oh, I was going to say, when we replaced the wire at Princeton, the reason why we had to replace is because they did do that. They tapped off of it and melted the wire.
Yep.
That's 500.
Was it aluminum? Aluminum cover? Yep. Guys, you know, when you design and install a system, safety start have 4-leg stool like I always say. Number 1 is the equipment have to be safe. You listed equipment. You can't make an unsafe equipment installed and designed safely. So equipment have to be listed, which I'm sure it is. That's number 1. Safe equipment, you listed. Number 2, design safe. So when you design, you take all these rules into consideration and design it safe. Number 3, the 3-leg, installed safe. When you send those electrician there, torque it, install it safe. 2 specification. Anybody remember the last one that everybody forgets? Now we install the system is up and running. What happened a year from today? Thank you. Maintain safe. These are the legs of the safety stool in an electrical industry. 4-legged. So what I'm getting to, if you just put them there and you don't maintain them.
They wrapped it with electrical tape.
Yeah, but what you need to do is typically they do it every year or every 2 years, and some people do it every 5 years. They go thermal image. Now it's easy. They open it, the thermal image, it gets hot. You can see it's hot. When it's hot means it's expansion and contraction. It gets it loose a little bit. So you shut down at the predetermined location. You go torque them, get the tape out, re-torque them, put them back, maybe change the lugs. That's called maintenance. So, because everything is like your car and mine. You buy it brand new, and if you don't maintain it, it goes down the drain.
They have a lot of bad scenarios too, like your conduit running up to the switches, in the substation. They were just directly open, like straight up.
And the water going right.
Water, yeah.
Oh my God. Yeah. So they don't have a goose head or something.
Well, we put one on when we put the new stuff on.
Yeah. I'm gonna give you guys 5 minutes, stretch a little bit, and then we'll continue. Thank you. Guys, tons of good information. So we'll try to get over as many of this information as we can. I'll show you a few of these pictures that you guys have. Table 310.104a. If you guys don't mind, if you guys go there, please. Table 310.104a. That will list to you the thermal insulation of all the conductors. I don't know if you remember, guys, we were talking about T, H, H, N. Brandon, if you see T, H, H, N, where would you install this cable? Thank you. Dry. The key word is really dry. Any place that's dry. If you see a T, H, H, W, where would you install this one? Wet. How about dry? If it works in a wet, would it work on dry? Yes. Or dry. Okay. So there's a cable that says, guys, THHN slash THW. Where would you install this cable? Okay. That's what a lot of contractors will have this installation, which says THHN slash THW. Do I care from outside or inside? Okay, so that's basically the most common ones. This table, guys, have tons and tons and tons of others. XHHW-2. So if you see an installation that you don't know what's rated for or where can you install it, Gary, what would you use to find this information? Right into this table. Awesome. Um, we talked about dry and wet. The key word, guys, whenever you see a term, whenever you see a W in the name of the installation, that's a hint that this guy is rated for wet location. If there's also XHHW-2. Now, if you don't know can anybody tell me what XHHW? Find it, guys, and tell me two things. Is it wet location and dry location? You can tell by just by looking at it. Okay, wet or dry. Another thing, is it rated for, what's the temperature rating for this boiler? 90. For what? 90? Yep, for dry or wet? Thank you. 90 for dry and wet. Okay, I want you guys to go to XHHW. There's no dash 2. Give me the temperature, the rating for that boy. 90 and 75. Oops, now we have two of them. 90 for what? Dry and damp. Thank you. Dry, damp. How about 75? Wet. You see that some of them, guys, have two ratings. So Gary, Tony, I didn't pick on you today. But that's why when you guys go to the 60 degree and 75 degree and 90 degree, you can find the same insulation in both of them. Did it confuse you when you guys went there and you find like XHW under 75 and under 90? Well, guess what? If you're doing it in dry and damp, 90. If it's wet, where do you go? 75. Am I making sense, guys, with these? Good. Circuit, several component. When you deal with circuits, like we talked about, guys, several things you have to take into consideration for the temperature rating of the equipment. And you guys are very familiar with that, I hope. Because we said the circuit, here's my circuit, logs, conductor, logs, equipment. So, and if this circuit breaker is rated for 75 degree, 60, this cable is rated for 90, and this is 75. When you size the ampacity of this system, which temperature would you go to? The weakest link, 60, based on this log. Now, if you were to change this, well, you go ask for 75 degree logs. You know, you're an engineer, say, I don't want 60 degree logs, make 75 degree logs. Now, if this is 75, which column would you go to size? 75. Does that make sense? The weakest link? And the weakest link of what? All of these. From the panels to snap switches, to splices, to conductors, to disconnects, wherever even the wire nut are rated for 75. If they're 60, the wire nut itself, you go to the 60, the weakest link in the whole system. Am I making sense, guys? So if you stabled here, you did a box, and you did a wire nut, and this wire nut here was 60 degrees. The whole system becomes what? 60. Who cares? You have to go to the column at the end, the column to find the ampacity of conductors. We talked about, can I drill in your mind the term weakest link? Weakest link? The lowest temperature rated component in the circuit. That's what the weakest link is in the whole circuit. Knob and tube. Have you guys seen knob and tube? In the old days, they used to do knob and tube wiring. It still exists in some building. It's a fire hazard because the insulation have deteriorated over the years. Now remember, that was in the 1800 up to, I think, gosh, the 40s and the 50s when they start moving away from wire nuts. If you ever wired an old house, you'll find weird stuff. You'll find one wire here and one wire here. So that will be your hot and that will be your neutral, not in the same cable. It's like utilities, type of work. So that's the old wiring. You can extend it safely, but you cannot wire with it. It's called knob and tube. A knob and a tube. Neutral sizing, guys. When you size a neutral, typically the neutral will carry the unbalanced current between all the ungrounded conductor. There are 2 rules for sizing the neutral. This rule, guys, will refer you to table 250.102C. Do you guys remember this table? When we size the neutral for the service. And these guys, I believe they allow you to derate 75%. If you don't have one. So long story short, these 2 references, Tony, my friend, that will give you the permission to have a neutral lower than the phases. And we did an example, guys. Remember the whole example that we did, sizing it? If you're at the service, this is service. This is yours. If you are feeders, this is for feeders. This is your references. 70% basically. And we did this one, guys, when we did the example, the example that we did with you, which you guys will do. Okay, voltage drop. Voltage drop, we talked about, guys. The way the electrical energy works, you need a pressure. The pressure comes from the voltage. If the pressure is not high enough, the equipment will not work. Done. You know what I mean? That's done. You have to have high enough pressure to push the current into the equipment in order for the equipment to work. It will, based on UL listing, guys, all equipments, typically a piece of equipment, when you have a piece of equipment, this is a piece of equipment, an AC, when it's rated for 230 volt, single phase, it says on that, this means it's plus or minus, UL listed typically plus or minus 10%. So you can go 10% higher and the equipment will not burn, and 10% lower and the equipment will not burn. That will allow the utilities like yourselves to up the voltage, lower the voltage, fluctuate the voltage, because the voltage is not constant, guys. Every time you turn something on, it dips. Every time you turn something off, it goes up and down, within a limit of what? 10%. If it fluctuates more than 10% up and down, it burns the equipment. Anyway, because of this, we have to maintain. The LEC code will cut this by half and say, okay, we would like it to fluctuate 5% according to the LEC code. And the way they do it, very simple. Here's my feeder. Here's my 100 amp feeder going to a panel. Here's my 15 amp circuit breaker. Here's my equipment. It's an AC, a window AC. This is my branch circuit. This is my feeder. Here's the component you can do, John. Number 1, 3%, typically, here's what the engineers do. 3% drop on the feeders, 2% on the branch circuits. For a total of what? 5%. Does that make sense, guys? 2%, 3%. Why would you do 3% on feeders? Anybody? Why not the other way around? Yes, feeders tend to travel further. Now, the NEC code book, does the NEC code book cares, guys, if you put the 2% on the feeders? No. But we always give 3% on feeders and 2% on branch circuits. Okay? So I need somebody to do me a favor. This system is 240. Okay? I would like you guys to tell me what's 2% times 240. Is 2%. 4.8? 4.8 volts. Okay? What is 3% of 240? Gentlemen? 7.2 volts. Add them up, please. What is 5% basically of 240? What would that be? 12? Even? 12 volts. Look what happened. I started with the voltage here, 240. By the time I reached this, I lost 12 volts. So that will be 240 minus 12 is what, gentlemen? 28 volts. So I can drop down to 228 and my equipment should function okay. You can see what the voltage drop. What happened to the 12 volts? The 12 volts got dropped where? Here's my 12 volts. In both the branch circuits and the feeders. On the feeder, how much did we drop on the feeder? 4.8. How much did we drop on the branch circuit? Or is that the other way around? Oh, the feeder is 7.2 on the branch circuits, 4.8. For a total of 12. Now, now my piece of equipment, if it sees 228, it will function okay. Any comments, guys? Any questions about that? You see the importance of voltage drop? Now, what happened if your voltage here is 220? It dropped too much. And then what they do with the equipment, guys, they make the equipment rated for 230 here. Even the manufacturers rate their equipment for even a lower voltage, 230. So you are now even within the range of, now remember, 230 plus or minus 10 based on the manufacturer. So you're within the range. You dropped a little bit lower than 230, you're within the range of this equipment. So you still function. Go lower than that, the equipment is not guaranteed to start. And if it starts, doesn't guarantee to run. And if it runs, it's not guaranteed to run efficiently. You need the equipment to start and run efficiently. That's why we give it its rated voltage, or as close to its rated voltage as we can. Comments, questions, guys, about that? So that's what your voltage drop. We talked about the feeders. The article that talks about these guys, I don't know, I highlighted it right here. This is the article for the branch circuit, or the section for the branch circuits. This is for the feeders. Same information I just told you, 3%. For a total of 5%. 3 on feeders, and 5 and then 2 in branch circuits. Okay. This is a couple of rule of thumb, guys, for approximate rule of thumb. Again, relationship between conductors. Rule number 1, wire size up to 4 odd. Every third size, you double or half in the circular mill. So conductors wire up to number 4. If every time you go to the third size, you double higher. So you go 1, 2, 3. Now you double the circular mill. If you went lower, 1, 2, 3, you cut the circular mill by half. Rule of thumb. So for wire sizes up to 4 odd, every consecutive wire size is approximately 1.25 larger than or smaller than the preceding one. So 1 odd and 2 odd. 2 odd is 1.26% larger than 1 odd. 2 odd is 26% larger than 1 odd. Circular mill. Do you need to know that? No. A couple of rules of thumbs. So that's basically it in terms of rule of thumbs. Let's talk a little bit, guys, about Romex. Romex, and you all listed. This is the article that talks about the Romex. It's for cooling. That's my article, non-metallic sheet cable. You are listing 719. Describe that non-metallic. It's called Romex. You hear the electricians call it Romex. It's the NEC code book does not call it Romex. It's called non-metallic sheet cable. It's not Amman, right? Many times I wrote Amman, Minnesota. Annam. What's Annam? New Mexico? Is New Mexico Annam? So it's New Mexico. Think of it as New Mexico. Not Minnesota. Don't flip them like I did. The most economical way of wiring dwelling or wood buildings. Any type of wood building. It's not just dwelling. Anytime you use a wood building, they call it construction 4 and 5 typically, which is made out of wood studs. You know that wiring method. So if you have I don't know, a strip mall made out of wood, you can wire this. If you're engineering a project, you don't use this. You use MC cable. So just be aware of that one. They make it in 3 types, guys: NMB, NMC, and NMS. All of them are B, guys, right? I want to emphasize the word C and S. Very simple. This is the general one. This guy is general. This is, you're looking at it here, NMP. The one that has the C looks gray. There you go, right here. Even though this is UF cable, it looks like this. Looks like a UF cable. It's meant to be installed in damp location, basically, because that's a dry location. Damp location, they have a C on it. And if it has an S, anybody remember what an S stands for? Signal. No, signal. So it's used to carry signal instead of power. One more time. The first one is the regular one. The one that has a C, it's meant to be installed in damp location, and it can handle the dampness. The one that has an S, guys, in it is signal. Same thing, but signal. So that's basically the three types. Again, there are multiple wiring methods in chapter 3. You guys will be talking about. We'll talk about a few of them. Each wiring has its own article. NM cable has 334. Each one has a lot of application and rules that you're going to spend all your life dealing. Here's the NM cable. NM cable, so when you're a project manager, Patrick, and you're dealing with NM cable, and by the way, this is typical for AC and MC cable bunch of them. So first, I want to highlight a few things. You have to stable the conductor within, can you guys see that? 12 inches of the box. Okay, that's rule number one. Rule number two, you do have to leave 3 inches, can you guys see that? 3 inches right here for termination inside the box, 3 inches for termination. And 6 inches from the point it enters the box. So Brandon, here's the hole, you're coming from here, 6 inches up inside the box. From the cover, from the end of the box, 3 inches for termination. 6 from where it enters, 3 inches from where it projects outside the box. So these are rules. Number 2, 4.5 feet in between. Can you guys see in between 4.5 feet, 4.5 feet, 4.5 feet? When you support them, stable them, you have to support them or stable them 4.5 feet. That's it. These are the rules of Romex and NM cable. So when your project manager walk away, you look at the Romex, you do your inspection before the inspector comes. A second thing, now what happened if you don't have, this is if you guys have an internal clamp. What happens if you don't have an internal clamp? Don't have an internal clamps, any of these. These have internal clamps. Can you see these little ones? Now what happens if these are broken? These clamps are broken, right? What happened? You broke it. No problem. Then this is the rule where applies. No clamps. You have to allow 1/4 inch of the insulation. Can you see that right here? And for all of them. And if you don't have a clamps, you have to stable with how many inches? 8 inches versus what? 12. That's all. No problem. Just stable them 2 inches less. 8 inches. That's basically it, guys. In terms of, can you put 2 conductors in the same hole here? No problem. Bring it on. If there's no clamps. The 6 inches is, there you go. That's my, so where the conductors enter the box, okay. From the point it enters the box, from here, all the way up to here, 6 inches. From here to here, 3 inches. It will be different than how big the box is. So typically, if you create it from here to here, 6 inches, you're good for most of the time, for all cables. And at the end, from here up, you will leave 3 inches for what? Termination.
So the box is deeper.
Is that the box you end up with a more conductor? Yes. Yeah. So. Okay. So these are a few rules, guys, about Romex. AC and MC cable, they have a rule, guys. We're talking about AC and MC cable. And the only difference between them, the one that nicer insulated neutral is called what? MC cable. That guy, that one that doesn't have insulated neutral is called what? AC cable. In terms of good and bad, which one of them is the best? MC is the best. So in terms of best to worst, here's how we go from best to worst, guys. Romex versus MC. So you start with MC cable at the top, in terms of cable, then AC cable, then what? Romex, in this order. in terms of better wiring methods. Um, MC cable, guys, AC cable is called BX. Why do I want you to know that? Because if Chad is not with you, which most likely I wouldn't, but I will be helping you guys when we do estimating. When we do estimating, and you go to the software, Patrick, they're going to be pulling. You're not going to find an AC cable. You find BX cable. So please associate BX cable with AC cable in this system, like Romex, NM cable. These are software guys, the estimating software, they use these slang languages. Or we'll talk about the tables in a second. A few things, guys, about wood construction. When you're doing wood construction and you drill the hole, where do you drill the hole for your cable? Right in the center of the wood. You have to clear 1.25 inches from both sides, 1.25 inches. Talk about this one in a second. If you have metallic construction, guys, the studs also in the middle of the holes will be for you. Okay, here's a few things. These are all rules, guys, from the chapter. Rule number 1: if you cannot maintain 1.25 inches by drilling the hole right in the center of the stud, you guys have seen studs, right? It was a change for me the first time I've seen the studs. Where I grew up, we built concrete blocks. Not a whole lot of wood, at least growing up. Anyway, so right in the center of the 2x4, and you have to clear from the edge of the cable. If you put it in the center, guys, no problem. 1.25 inches will get you there. Now, what happens if you can't? No problem. All what you have to do is put that little blade. I don't know how many of you guys have seen this blade. It's sized as 1/16 thick steel, and you put it right. Anybody knows why? Sheetrock screws. When you put your sheetrock, you want to go right through the cable. So if you can't maintain 1.25 inches, you just have to put that little place. They sell them at Home Depot and everywhere else. Put it there and you're good to go. Same thing if you're doing groove. If you're grooving here, you're cutting right through just a little groove to put your cable. No problem. Go ahead, but you put the metal. So that's basically it, guys, in terms of 1.25 inches. Steel plate. So if you can't maintain 1.25 inches by drilling right through the center of the 2x4, drill anywhere you want, as long as you put the steel. We always want to drill for in the center of the stud, guys, because also from a structural point of view, you don't want to drill anywhere else. So the rule is in the center, unless you can, then you go drill wherever you want and put the plate. Okay, so these are a few rules about installing cutting grooves into the building because there is no hollow spaces. Again, like I said, the rule is to put them in the center. The exception is to cut grooves because you don't want to mess with the structural integrity of the building. Remember, you guys drilling holes. You have I always tell the people, you can drill hole anywhere you want, but be careful not to bring the building down too. So as you drill there, we are disciplined. We're one discipline of multiple. So if you have a beam, a wall bearing a weight bearing beam, you go drill right a 2-inch hole right through that beam and bring the building down, you wouldn't. So when you drill, that's why electricians and you guys, a project manager, you're going to be looking at the structure. Avoid drilling in any wall or typically beams that's bearing weight. You don't want to compromise the integrity. Okay, metal studs. You guys are familiar with the wood studs, typical for all residential. Can you use metal studs in residential? Yes. Commercial, industrial, they use metal studs. If you use Romex with metal studs, then you have to have these plastic things. You put them in the holes. Anybody knows why? What happened with this when you pull it through metal, sharp metal? You cut it. So you want to protect the cover. You put that little plugs in to protect them. Non-metal cables and to run holes and blah blah blah. So you're required to put these little protectors to protect the cable. Are they required with MC and AC cable? Look at it. How are you going to cut right through that by putting it through a metallic hole? It got to be a really sharp hole to cut through that. Very sharp, and you sit there and you just try to cut it. So you can't. Okay, now have you guys seen when they do heating and cooling? Sometimes they use the cavity. I assume a lot of you have seen. I had a student one time. I stayed in an attic, and he had never seen an attic, and he was a new immigrant. And I was a new immigrant. I had never seen an attic in that term, to a wood attic, until I climbed into one. So if you haven't seen that, let me know, guys, if you haven't seen any of these. Because knowing the construction, how we build buildings, will help you design it. We have to know a few things about building. Okay, now with the dual studs, the 2x4 studs, sometimes you use the cavity between the studs as you return for the air, not the supply. The supply is always ducts. They put a duct, right, to heat. But the return, the air that you push have to come back and be circulated. If they're used only, and the way you know it by putting a fixture right here, you see a vent, and you look above it, and there is no ducts. It's just a little vent at the bottom. This means they're using the cavity as a return. If that's the situation, then you cannot pull any wire vertical like this. You can put horizontal, no problem. Like cut right through it, no problem. Because you have to. You need to go from point A, but can you pull vertical? No. That's it. That's a rule. But remember when, this is only if you're using the cavity. If they have a duct here, like this, a duct tied to it, I don't care. Then I can bring anything I want on this wall. But if they're using the cavity as you return, and if it was a supply too, typically they don't use it as supply. You can't even do it if it's supply, and they don't do it as supply. Okay, so these are a few things, rules, guys, about the installation. Through the ducts. Now here's a duct, a heating duct, and right through the duct. Can you install a cable through the duct that heat and cool? No, with very, very exception. Only the exception, we use rigid or MC cable only to tie to equipment. In a commercial is coming, guys, you have a sensor right here, and I want to go through to the sensor. I can go the MC cable or rigid or whatever, only to get into sensors inside the ducts. Are you guys following with me? These are ducts that heat and cool the building. They don't want you to use the duct as your wiring method, so let's pull the cables right through the ducts. So no. And it's all about the safety. All this are safety related, fire. Many have a built-in clamps. When you, like I said, these are the built-in clamps you're looking at them, guys, right here, are either plastic or if they're metallic. The metallic ones, I don't know if they have some of them. Some of them I don't have the side. They have also the clamps inside them. The clamps, guys, when they have a clamp, they either have the clamps rated for one cable or multiple cables. So the inspector catch you if it says a one cable clamp and you put two cables underneath it. Oops. No, we have to remove it. So be aware of the rating of the clamps. Typically they have them for two cables, So here you have to put one cable under each one of them. But if you break it, then you can put as many as it fits. So, because now you stable it, remember you're stabling it 8 inches from the box, not 12 inches. Okay, so that's a few rules, guys, about Romex cable, the most common. Any comments, any questions? I'm going to run you through all these articles, guys. Now, remember, rule number 1, Romex cable, MC cable, AC cable, Romex. Now, if you're going to go to conduits, guys, your conduit of choice, we just talked about this one. 95% of the time, EMP. You're looking at it right here. Now, what happened with rigid? Now, this is your conduit of choice. What is it? 90% of the time. Now, what happened to this and this? These are rigid metal conduit. The only difference between them, look alike, guys, they have a thicker shell. This one is when Chad is mad and he wants to hit that with his fist or kick it. That protects you from something like this. Can you guys bend that one by hand? Gotta be really strong. Can you bend it by hand? You probably can. Yeah. So it's still strong. Now, but this is not strong enough to handle my car driving into it or yours. If you need more strength than this, which is really strong, think about it, really strong. You need a car to drive or a fork or something to drive right through it. If you need more strength than that, then you got yourself rigid. Rigid, guys. It's looking at rigid. Thicker. Now, I guarantee if you put this one in the wall will come down before you bend that one. If you ran a car into this, that's a weird thing. Is they want you to put these on the places where closer to driveways. Now, if you put this one and you hit it with your car, the wall will cave and this is still standing, or it will go the wall. You know what I mean? They're really thick. thick stuff. They use them a lot in an industrial where forks are running all the time. So, accidents happen. You don't want to shut down the power system because somebody lost control of his forklift, and ran into a power, so they use them a lot, the rigid. That's it. The same, looks exactly, I don't know if you guys can tell from there, if it doesn't have any. These are also threaded. These are, you can't thread this, but this is also come threaded, so stronger. Instead of you slide the connector in here, these are, you have it threaded here. Where would you use this one? This is in severe physical application. Manufacturing floor, forks running around, forklifts running around, service right next to coming out of the ground, right next to a parking lot. Chad is drunk, ran right into it. You know, um, what else? Hazardous location, gas stations. A lot of hazardous location. Aircraft hangars, gas stations, or anything that has flammable gases or liquids, they use this. So when you think rigid, think really severe physical protection and hazardous location. Okay, what's the intermediate though? The intermediate, guys, this is how thick that is compared to this. I don't know if you guys can see that. There is one in between them, a size in between them. So from a point of view of a code, the intermediate and rigid are treated the same. So the severe physical protection. So that's what you do. So why would you use conduits, guys, in the places where you can't use a cable? Specify installation. Flexible. Now back to the flexible here. We talked about the flexible. If you guys can give me one word for using flex, one word, what is it? Flex like this. Tying to machines and equipment. That's it. Yes, sir.
One of the factors that we were in diesels just for the corners, I saw mostly.
For the corner, going around the corners?
Conduit running down the wall and it just turns.
Oh, they don't want to bend. They use them as a connector, not to bend. So, yeah. But if you here's the problem: if you use them around the corner, what you're saying is, yeah, there are fitting that takes you from this to this, by the way, directly. You don't have to go. Just a little fittings, not this one, but it will take you from this wiring method to any wiring method, basically. If you use it around the corner, this guy by itself is not qualified as an equipment running conductor. This is. This is an equipment run. This is a green conductor, believe it or not. That's qualified. Now, if this is not qualified and that's qualified and you put them together, the system becomes unqualified. So you need to pull what? A conductor. And when you push when you push in wires, this will be a weakest link. It will be hard to push through. Can you do it? Yes. It's a sloppy job, though. I'm sure they have a reason for doing it, probably.
You know, it was the funniest part. It was inside. We were working inside the electrician's shop for that plant.
Well,
That's what.
so they're coming from here and then continuing with another one.
Conduit to run down the wall, then when it went.
They just don't want to bend it. Yeah. They want to do the bendings. Yeah, it's a lovely job. Will it work? Will it meet the code? Yes, if you put a conductor in it, an equivalent conductor. Okay, gentlemen, this guy is for what? Vibration. Can you guys transfer vibration and simplify installation? So when you type your equipment, you will work on the equipment to unplug it, move it to the side, work on it. Ease of installation as well as absorb the vibration as the machine vibrates. Other than that, using them will be a waste of time. Can you use them to wire the whole building here? Yep, no problem. You have to pull an equipment running conductor in it. It's not approved. So, okay, PVC, gentlemen. You're looking at the PVC right here. What did we say about the PVC? Conduit of choice when you go where? Wet or underground? I like the word wet because what if you are in a car washing machine, car washing a building? Wet, it's not underground. If you guys ever look at the wiring methods in a car washing area, you see a lot of PVC in it. Why? Corrosion. Conduit of choice for corrosion. Now, what the heck is the ear, nose, and throat doctor here? You guys, the ENT, I call him the ear, nose, and throat doctor. The ear, nose, and throat ductor, guys, is basically another PVC conduit, non-metallic, electrical non-metallic tubing. They call it tubing, used in power. You can use it for power or communication. Any one of these, by the way, you can use any one of these can be used for power, communication, or signals, whatever. Okay, so any one of them. But typically, the reason why they use ENT, two locations for it, guys. If you need minimize interference, you use non-metallic. I don't have an example of it. to minimize the interference, because if you put metallic, what happens to the metallic and you put the metallic like this? This acts like an antenna. You do low voltage. If you put this like this and you ground it, isn't that an antenna sitting up in the air collecting signals? It could interfere with the equipment, sensitive electronic equipment. So that becomes not a good idea for sensitive electronic equipment. You can put this one or ENT, or they use them in highly corrosive environment like barns and what's not. Highly corrosive environment where a lot of corrosion that could happen. If you put steel, it will rust. PVC, bring it on. Another option for the PVC is called ENT. So I always tell the people, think of ENT as another option of PVC, except it's more pliable. It bends easier than that. More pliable. You bend this one?
They got pre-made then.
Yeah, for bending. Yeah. Yeah, they're bending these guys. For these, they have hand benders and machines. For this guy, yeah, for this guy, like you said, they're a blanket or a heater or a box. So you heat it, and you have make sure you put your gloves on, and then you bend it to desire. Now, if you're Chad, you might make it like crooked a little bit. You gotta have some skills because you're really eyeballing it when you're bending it. There are other methods to do it, but for the most part, you're eyeballing it. This one is almost science to bend it. And we have a blanket, yeah? Yeah, you burn it. You burn a hole through it too if you continue. Okay, there's something called surface entrance conductor, guys. Where's my surface entrance conductor? Here you go. This is. Okay. No, this is an NMB. This is, look at this. This is an NMB number 8, guys. This is also NM number 8. See that they're color coded. I don't have a service conductor here. I thought I did one time. Did you guys steal it? No? Anyway, it looks something like this, except it's twisted. That's your service entrance. Typically, the way we use it, guys, we use it for barns. From the pole in the middle. If you, I'm sure you've been in farms. They have a pole right in the center of the farm, and then they take it from the pole in the center to the second pole to the third to go to the barn and the shed and the house. That's one major application for residential, for a farm, and also we use them for dwelling. The utilities use that cable to bring the power, the service drop into your building. So that's why they call them service entrance cable. You bring the power into your building with a cable like this. So there's a few of them. There's an article about them. Run from the utility service drop to the meter, then from the meter base to the meter service panel. So the whole service installation. I'm going to minimize this, guys, and take you quick through my slides here. So let's go. We talked about the branch circuit, guys, junction box and branch circuit multi. Do you guys remember? Look at these and tell me what's the rating of this circuit. I have number, we got that one, number 14. I have number 12, and I have number 10. What is the rating of this circuit? All of them? 15 amp. It goes by what? By the overcomputation device. Good. So moving on. This is a connector. Remember the set of connectors, typical. You bring your conductors in here to tie in. So this is, the pictures are so nice, guys, because you're going to see them in the industry. So it helps you understand. And okay, we talked about the lugs, different type of lugs, right? Here's the Romex. If you've never seen a Romex, how it looks like. Number 2, I'm sorry. Number 2. So here's my number 2. Can you guys see? This is a hot and this is a neutral. There are 2 different wires. That's violation of the code. They're not bare. No, they're covered with an insulation that deteriorates a lot. So it's really dangerous. They're still working though. You'll be surprised how many homes in the U.S. are still running with these wires. But here's the knob and tube. It goes through that tube from point to it, and it sits on a knob here. What the violation is, the code says right now the hot and neutral must be in the same cable. Can you can see that? That's a major violation of the code because of inductive heat and what's not. So we don't wire for it from this wiring system, but be aware that it exists. We talked about 240, 120 single phase system, guys, two loads. Oh yeah, when you have single phase 240, the system that we use in the US, you can feed two types of loads. This load, guys, is called 240 load. This load and this load are called what? 120 load. So be aware of that. Unique system, and there are equipment that take only two. This is two wire. This is also two wire. An equipment right here that's actually 240/120. So how many wires is this? 3 wire. Do we count the neutral when we at the ground when we say the in addition to the ground? So a typical example of this one is the AC. A typical example of this one is your range as well as your dryer. So the way they do the range and the dryer, guys, the heating element in the electrical dryer will be 240, that guy here. This is the 240. And the motor itself is 120. So they run the motor at 120 inside the same machine. So when you have 240, always ask. If you have a machine that you don't know, when you have a 240, always ask. 240, do I need a neutral? The machine might need a neutral or not. Like an AC here, just 2 wires. A range, 3 wires, 2 hunts and a neutral. So how would you know? You really wouldn't. Unless, how do I know? Because I've seen them and wired them. You know, if you go commercial industrial now, they have a machine, a medical machine, 3-phase. The first question would you ask is, do you need a neutral? Who would you ask? The guys who specified the machine. Do I need neutral? 3-phase. Do I need neutral? 90% of the time, no. The answer would be. So, but you have to ask that. Okay, we talked about the voltage drop, guys, and we almost will do a voltage drop calculation. And we said about the 3% and the whole calculation system here. Do you guys know, in terms of voltage drop, the higher, look at this, if we have a 3% voltage drop here, you start with 120. What's the voltage that you end up here at the load? 116. So, do you see now in the US, we use 120 for most of our stuff, right? In other parts of the world, they use 220. You see how 220 becomes superior in terms of voltage drop? You can lose a lot. That's why when I was wearing overseas, you have a 15 amp circuit and 10 amp circuit, and it gets a lot of juice out of it. 10 amp at 230, you have a lot of juice. 10 amp at 120, not a whole lot of juice, half of it. So, but we're stuck with what we have. That's why you go to 480 system. Most major part, you can push more power. Okay, here's your voltage drop. We talked about this one, guys. This is probably one of the best illustration of voltage drop. The engineers use this. They use 3% on feeders and 2% on branch circuit for a total of no more than 5%. Can you do it the other way around? Yes. Not common. Why 3% on feeders? Feeders are always longer. Okay, here's your NM cable. We're just looking at it, guys. 2 conductors insulated and 1 not. Different tools. We talked about this one. When you come with an NM cable, guys, from the ground, you have to put it in a PVC to protect it from physical damage. Protect at least 6 inches above ground. This is a sloppy job. When Romex, guys, are meant to be insulated inside the walls. If you put it outside the wall, it looks really ugly. But if you do, then you have to put a conduit up to 6 inches to protect it. So Chad, when he's mad at his kids and he pushes the chair, doesn't cut right through it. When you're drilling, guys, your holes, you can group them. Thermal insulation. So like here, you bring all your cables. If you put thermal insulation here, so you thermally insulate this, then you have to derate. So how many cables? Let's just say this is 14. No, should be 12. 12 tools. 1, 2, 3. So 3. Each one of them is carrying times 2. That gives you 6 conductors. Carrying conductors. How many are we allowed to put in one conduit or cable? 3. So you have to derate. That's one place. If you put, when you cut this area, which you have to for thermal insulation, then you have to derate. This is just a couple of things you have to pay attention when you do installation. These are the stables that you have to stable, guys. Different stables and connectors. Look how they stable them. You can put two together, but you can't put them this way, right? And again, all the rest of them, guys, I know if you're a designer, like I'm sure probably you wouldn't care about this. If you work as a project manager, you're going to be looking at the people working, and you see something like this before the inspector comes, so you can't do it. That's violation of the code. You have to be flat. It's meant to be flat. So a couple of rules, guys, about bringing him and attaching him to the bottom of the, look at this here. Okay, 2 number 6 or 3 number 8 can be attached to the bottom. Smaller than that, you have to drill holes. Can you guys see? Cable sizes may be run through. So that's they always, you guys are not electricians, but they always catch you on. If you have 2 number 6 or larger, or 3 number 8 or larger, you can run them down. That's in the basement, in the joist. Other than that, you can. Or you can drill right through them. Or you can drill right through them and pull your conductors. And that's now you're getting it through the installation. Tab holes for ground screws. There's some ground screws here. Tab holes for ground screws. You have to ground them. Here's a couple of hardware. You ground the box. All the stuff. Now bringing the cables into the panel. Can you guys see how you bring the cables into the panel? Type of the fitting is that. So you can. Why would they use that fitting? Interesting. You see, coming from the top here and bringing all your cables onto the panel. Looks like a PVC fitting. Huh. Right? PVC fitting. Here's another way, guys. Now, when you go to the basement, can you put the NM cable on a concrete or block? No. So what they do in the basement, where it's not finished basement, they typically come up with an EMT conduit. You can see like all the way, and they put their boxes against the block concrete basement. Very typical application. And you have to stable it within 12 inches. Can you see that within 12 inches of the enter? And then you apply the rules of typically 3 feet in between. So that's a typical in basements. You see them all the time coming with an EMT conduit. Why? Physical protection. You don't want to put Romex in the basement on the concrete. If it's finished, that's a different story. It's finished, finished. Here's another way, guys, of coming through the top. They allow you to group them all in a 2-inch or whatever size you come, and come with all your branch circuits together, 18 inches up to 10 feet, no more than, not smaller than 18, not more than 10 feet. You group them at the top. You have to stable them within 12 inches of entering here. So you see all these guys, how people bring the branch circuits into the panel with this NM cable. All these pictures are for you guys to visualize and see how installation is done. Okay, here's your MC cable, AC cable looks like. Termination of AC cable. For AC cable, they use this one, guys, the short, anti-short thing. They stuck it in here before they plug it. There's a machine that can get rid, remove the installation. We use them up there. Talked about these one and the edges, bringing them to the boxes. Look how the hardware that you can use to bring multiple, very nice. There's something called workmanlike manner, guys, for electricians, with the inspector walk in and say, wow, great job, and meet the code. And you walk in and you say, wow, sloppy job, but meets the code. You know what I mean? So there's something to be said about making things look nice by using the right hardware. Look at that. Now I can make these, take these, how many cables? 1, 2, 3, 4. I can put them stable 2 by 2 of them right on the stud here, but they have this little hardware here that makes it look nice installation. We talked about that little sleeve, talk about that one. Grooves, if needed, and where you have to protect them. Different type of hardware, talked about. Oh, by the way, also in that cavity, the air cavity, can you put a switch or a circuit breaker here? In the air, this is where you air return. Can't do that in your air return. Different hardware that guys comes with the connectors. You know, I always tell the people the hardest thing, guys, about wiring is knowing what hardware goes with what. It really is. There's so many of them. Like for example, you have a connector for this and coupling for this. The connector that works for EMT does not work for PVC. Even though they might fit, you put them in, they fit. They're violation of the code. When you stable this into the wall and this, they might not have the right stapler. That one works with that, but not the other. So how do you know? It's all the hardware that goes with it. If you have conduits, typically guys for conduits, we support the conduit 3 feet and 10 feet in between. 3 feet, 10 feet in between. 3 feet from every box, 10 feet intervals if you have conduits. If you have different conduits. Here's different type of cables and this guy, where did it go? Flexible metallic conduit. This is guys only approved for dry location. Now what happens if you have a little bit in a roof? It's like in Minnesota, they put a jacket over it to protect it from the element. It becomes like this. This is what you're looking at here. If you put it in a wet location, this does not qualify. This is dry only. Then you have to use watertight flexible metallic conduit or non-metallic conduit. Different fittings that have to go with it. The fittings that goes with this guy is completely different than the fittings that that goes the watertight. The watertight fittings have to be watertight fittings. That's how the inspector catch you. Here's a fitting here. I can make this fitting work with a watertight. Well, it's violation of the code. If this is watertight, the fittings have to be watertight. Am I making sense how knowing the hardware, different hardwares that you can do? Tying to equipments. Look at that little fitting that take you from flexible to EMT, guys, here. There's a lot of fittings that can take you, or from box to EMT. When we bend the cables, you can't bend any cable more than any 360 degrees. So can you guys see when you bend that cable here? So don't go nuts bending the cable or the conduits. Typically conduits, can you see here's 90, 90, 90, and coming over here. So here's 90 and here's 360 degrees. I can't go bend that one up and down and bring it like this. If it's a conduit. Cables, who cares? Conduits, 360 degrees. What happens if you need to bend it more than 360 degrees? Thank you. Go to a box. Different type of installation, guys, support and conductors and what's not. Moving from different box, different wiring methods, liquid tight flexible metallic conduits into flexible metallic conduits, connectors and boxes. Here's liquid tight flexible metallic conduits tied to a box, typical for AC systems. You know, so these are a couple of rules, guys, for the flexible metallic conduits and what's not. They allow, without getting into the details, we're engineers, so we always say, guys, if you're using this, pull an equipment around a conductor. Always. The code allows you not to pull an equipment around a conductor. Typically, if you have a cable like this, tied to a fixture web like this, then you don't have to have a ground. You can ground through this, guys. But our rule as an engineer, always when you use this, what do? Pull an equipment around a conductor. Even though there is exception. What's the exception? You're tying it to a fixture. With 20 amp circuit, you don't have to pull an equipment around a conductor. Here's your flexible electrical non-metallic conduit. AC cable, different type of AC cable. A lot of info, right? So, and I want to just show you guys a couple of these because I want to finish this one. This is a table that tells you where you can use different type of tables, different type of application. For the power industry, we start right here. These guys are, can you guess what class 2 circuit? Class 2 circuit signaling. These are signaling. Power cuts right here. This is from here down is power. So please have this handy when you're using your, because look at this. It gives you, here's the number 8 and 14 amp circuit. And where does it typically use? ranges, ovens. So since you guys are not familiar with the wiring, this will summarize the whole wiring system for you in one page. What we're just talking about in dwelling. Um, Conductor size and 3 conductors per carrying conductor. Um, Conductor maximum overcome protection device. We talked about this one last time. Devices, guys, like these, it will say copper aluminum and the conductors. So this is just when you're looking at the devices. For example, let's just take one example here. And oops, here you go. If 15 and 20 amp receptacle, you're looking at it. If it says COALR, what does it mean? Bring aluminum or copper to it, right? Or copper clad. You guys know what a copper clad is? It's a hybrid of copper and aluminum together. If it doesn't say anything, then you have to bring copper or copper clad. If it says AL or CU, aluminum, copper, copper clad. So this will tell you if none, it says cover only. If you don't see anything AL on it. So the rule, guys, unless you say aluminum on the devices, it's rated for cover only. Am I making sense? Unless there's some AL on it, it's rated for cover only. And the same thing, wire nuts. Look at that, here, wire nuts. If it says AL, aluminum only. If it says ALCU, aluminum or copper. So that's the rating for the equipment, you all. This is a summary of all the installation, guys, the commonly used installation that we use. Very, very important. I'm going to highlight 2 of them, and you guys will go through the rest. I'm going to highlight this one. We talked about 90-degree and this one. And you guys know the difference between them, right? Wet and dry location. So that's basically it. There's a bunch of UF cable. Yes, good one. UF cable, guys, if you're using it indoor, you treat it like Romex, basically. And you use 75-degree for the rating and what's not. UF cable is another typical, looks like a UF cable is like NM cable, except when we use it direct buried in the ground. That's the key for it. We treat it exactly like Romex, exactly, except you can bury it. Okay, so these are the overcurrent insulation ratings. And I talked a little bit, guys, we use the weakest link, right? For temperature wise, you choose the weakest link. This is circular mill for different sizes. Can you guys see that, for example, number 8 is 16510. These are coming from table, chapter 9, table 8. We looked at that one. The ohm per foot, this is also chapter 8, chapter 9, table 8. Uses permitted for non-metallic conduit. I'd like you guys to highlight this one. I don't have to, I don't have time to go over all of this, but I want to highlight one thing, NMC. I want you to look at NMC here. And if you look at NMC, look at damp or wet location. So inside wall of masonry block or tiles, where do we use that one? Here's a use where it's not used here. May be installed or fished in hollow voids or masonry blocks or tiles, walls were exposed to excessive moisture. Can you see that word, excessive moisture? Can you use the regular NM? No. Can you use the NMC? Yes. Excessive moisture. That's the key point for him. Excessive moisture. As for signal. Signal. So that's summary of all these. Rating of overcap protection device. This you might have to keep this handy, guys. We've talked about this all the time. You know what, Jay? When you start circuiting, guys, and you say, Chad, what circuit am I going to use here? What type of conductor? Well, remember the rules for, say you're circuiting a living room. Well, your default in the living room is what? 15. Now, when you start circuiting and you're doing, you guys are going to be doing takeoff on this project. Say, Chad, well, what type of conductors am I going to be taking off? Well, your circuit is 15. It's going to be number 1. 14. So this comes very handy, guys. It will when we talked about this, it's nothing new. 15, 14, all the way to different sizes. copper or aluminum. Look how aluminum becomes 12. So sizes of conductors, equipment grounding conductor that comes with it in the cable, guys. So if you have number 14 goes 14, 12, 12. With 8, 6, and all the way to 6, you use number 10. The equipment ground conductor in the cable on the conductors are typically smaller than the ungrounded conductor. And I'm gonna stop right here, guys, because I want to spend some time on the other tables. They're really nice. If you have a chance, read through them, but I'm gonna stop right here. The rest of them, all these tables that you guys are looking at them, they're identical. They're comparing all these wiring methods together. I cannot emphasize, Brandon, this chapter is one of the best chapters in one chapter that gets you a full overview of the whole wiring methods in the code in one chapter, colored tables, and I know a lot of information, but really good info. I'll go over this one, guys, in another time because I need more time, and I know I don't want to put you to sleep on a Tuesday after the Labor Day. Okay, let's take maybe 15, guys, and then I'll walk you through a few things about CAD, and we'll go from there.